degrees and radians. So remember that we learned a little trick with this. We know that converting back and forth, we're either going to be multiplying by pi radians over 180 degrees or 180 degrees over pi. So now remember that I did teach you a little trick. You can ask yourself, okay, what are we converting from? Degrees to radians or radians to degrees, and whatever you say second is what's going to go on top. So we're converting negative 200 degrees to radians. So I'm going to write that. We're going from degrees to radians. I said radians second, correct? So that's what we're going to put on top. So we're going to multiply negative 200 degrees times by our radians go on top. So we're going to multiply by pi radians over 180 degrees. Now this is where your calculator comes in handy. You're going to pull out your graphing calculator. You're going to type in negative 200 divided by 180. Hit enter and then change it back into a fraction. It will simplify it for you, in other words, right? Your graphing calculators will simplify it for you. So if you type it into your calculator and you do negative 200 divided by 180, make sure you don't type in the pi part, because we're going to leave the pi or else you'll die, as Cecilia has said. So this simplifies to be negative 10 pi ninths. So if you were to type into your calculator negative 200 divided by divided by 180, and then you convert it back into a fraction, you're going to get negative 10 ninths. So we write it as negative 10 pi ninths. Pretty simple, right? Now let's do the other way. We're going to convert 5 pi ninths into degrees. So once again, this one we're changing from radians to degrees. I said degrees second, so our degrees go on top. So we're going to multiply 5 pi ninths times by our degrees goes on top. So 180 degrees over pi. Now the nice thing with this is automatically we should know and see that our pi's divide out. That's the whole point of multiplying by 180 degrees divided by pi. So our pi's divide out, and then on your calculator you can do this many ways. I just type in 5 times by 180 divided by 9. It will give you the answer. So I would do 5 times by 180 divided by 9, but there's many ways of doing this. So that would be 100 degrees. So they're equal, guys. 5 pi ninths and 100 degrees, they're in the exact same spot. They're equal. They're just different forms. Radians to degrees or degrees to radians. Okay, questions on that? Okay, moving on to the next example then. So now looking at this one, it says draw an angle with the given measure in standard position. So you guys, I'd be watching this one because this is different than what we're used to seeing. We're used to drawing an angle in degrees, not radians. It's kind of hard to see where radians fall. So what should we do? Convert it to degrees. Let's just convert it to degrees because then it's easy. So we're going to convert 10 pi thirds into degrees. So degrees came second from radians to degrees. So we're going to have degrees on top. So 180 degrees divided by pi. And now our pi's divide out, which is what we wanted. Then on your calculator, you'll do 10 times by 180 divided by 3. And you get 600 degrees. So I would convert it to degrees because it's going to be a lot easier to actually put where 600 degree falls. Now we know that since this is positive 600 degrees, we're going to be moving this angle around in the counterclockwise direction, right? Counterclockwise is a positive degree. So then there's many ways of thinking of this. Most of you can just see it, but what I think of is, well, a full circle is 360 degrees, right? So we at least have to go a full circle. So I drew in my full circle, but we're going to keep going way past that, right? So then I go in pieces. So then I'm going to add 90 more degrees. Now let's see where that puts us. So plus 90 degrees. And then I'm going to go 90 more degrees because we're not quite there yet. So plus 90 degrees. And at that point, I'm at 540 degrees. I need to be to 600. So how many more degrees should we go to get to 600 degrees? 60 more degrees past that point. Does that make sense, everybody? So we need to go 60 more degrees to get to 600. So we're going to go another 60 degrees. So think about it. Right there is about 30 degrees. Right there is 45 degrees. And somewhere right about there, so going to there would be going 60 degrees. So on the test, you would want to put something like, okay, from here to here we went 60 more degrees, or I wouldn't mind if you put from here to here 30 degrees just to prove to me you know exactly where you are. Does that make sense, everybody? One or the other at least. Because if I can see your drawing and then at least how far you went to get to there, that is 600 degrees. Okay. Questions?
Can you go back to the last slide?
Yep.
Don't think about that.
Okay, so on this one I would definitely be watching because this one is the one that gets people, but it shouldn't. This is actually quite simple, but this is the one where it says, now notice it says find the exact value of each trig function. When you see the word exact, it should, like, you should automatically know I'm going to be using my unit circle. And you guys have to have that memorized. So I have blank ones if you need to practice that a few times today. Okay, because it would be a bummer if you knew what you were doing and you didn't have your unit circle right and then you got a wrong answer just because you didn't have the unit circle right. Okay, so it says find the exact value of each trig function. So it wants us to find sine of negative 330 degrees, cosine of negative 330 degrees, and then we didn't talk about this, but because I thought we were going to skip it, but we're going to talk about tangent. So this is something you have to learn today quickly, but it's really quite simple. So let's quickly, though, start with sine and cosine because we've learned those. But first of all, now if we're going negative 330 degrees, that's moving clockwise, right? It's kind of hard to see where negative 330 degrees lies. So I would rather just find the coterminal angle because it falls in the exact same spot, but a positive angle. Because those are easier for us to see, right? It's easier for us to see 45 degrees than negative whatever. Does that make sense, everybody? So to find the coterminal angle, it means it lays in the exact same spot. We can do our angle plus 360 degrees, or you can do your angle minus 360 degrees. So this is my personal preference. I don't want to have to look at the unit. I don't want to have to think about where negative 330 degrees falls. So I'm going to find the coterminal angle. So I'm going to take negative 330 degrees. I'm going to add 360 degrees because remember that's the lie in the exact same spot. So that is 30 degrees. Isn't it way easier to look at 30 degrees than negative 330 degrees? It's the same thing though, exact same thing, but an easier way of looking at it. So we're going to actually look at the sine of 30 degrees. Now remember that we just look at the xy points. So looking at this, remember that given xy points, that our x value is our cosine and our y value is our sine. Okay, this is the new part that we're going to quickly learn. So tangent is sine over cosine. So tangent is actually going to be your y value divided by your x value because y is sine, cosine's x, so y over x. Does that make sense, everybody? Really quick. Okay, so sine of 30 degrees. So I'm going to look at my unit circle. You'll have you filled it out at in the test at this point. So we're looking at 30 degrees here. Now let's look at our xy points. That's all we need to find sine, cosine, and tangent. So 30 degrees, at 30 degrees we have the square root of 3 over 2 and we have 1/2. So what is sine of 30 degrees? Sine is the y value of that point, so what is it? 1/2. Okay, so what's cosine of negative 330 degrees? It's the square root of 3/2, our x value. Any questions on that? Square root of 3/2. Do you have questions on that, guys? So then the tangent is y over x. So you'll take your y value divided by your x value. So our y value is 1/2 divided by our x value, which is the square root of 3 over 2. Now we're dividing fractions. Hopefully we're okay with dividing fractions. Now, dividing fractions, as easy as pie, flip the second fraction and multiply. So we learned that little saying. So we're going to, dividing these two fractions, we're going to grab the second one, we're going to flip it and multiply. So this is the same thing as 1/2 times by flipping the second and multiplying. So we're going to have 2 over the square root of 3. So then multiplying straight across, this is going to simplify because 2 divides by 2. And then multiplying straight across, I have a 1 left on top and a square root of 3 left on bottom. So 1 over the square root of 3. And then, is that how we write our final answer? No. We need to rationalize the denominator because I can promise you on the ACT tomorrow you will not see it written like this. So don't let it throw you off if you don't see it written like this. We need to rationalize the denominator. So what do we multiply the bottom and the top by? Good. So we'll multiply by the square root of 3 over the square root of 3. So then multiplying the top, we'll have 1 times the square root of 3, which is just the square root of 3. On bottom, we have the square root of 3 times the square root of 3, which is the square root of 9, which is 3. So on the test, on the ACT, and on our test, you're going to see it written like this. The square root of 3 over 3. Because it will be multiple choice most of the test. Questions on that? Okay. So tangent's the new thing. You'll just do y divided by x. That's it. Okay, moving on. We just have 3 more examples, and then I'll set you free. You'll have plenty of time to work. Stay with me for a second. Looking at this, it says graph the following function using gradients. So we're pretty good at graphing, hopefully. If we follow those little steps I give you, it's not too bad. So I'm going to just draw in my little thing, my little XY chart here. The first thing we do, is look at our shift left and right, up and down. So where is the shifting left and right? Left or right? Good. We look inside the parentheses, and then we always go the opposite of that. So we're shifting left pi fourths. So we're going left pi fourths, and then we're going to go what? Up 1. And then what's added on the outside is our shift up and down. So then we're going to go up 1. And we stay with the sign on what's added on the outside. So let's put in our new starting point, our new origin, we call it. So we're going left, we're going backwards pi fourths, so that'll be at negative pi fourths, and then we're going up 1, so right there is 1, and then I'm going to draw in my new XY plane here just because it's easier to see this way. So we have this next new XY point. So right now we're going to ignore the black line for a second. Now remember, this is where we used to be starting, but now we're here starting right there. Okay, so our first step is done. Second step is to graph your amplitude. So what is my amplitude? So our amplitude, I can't talk and write at the same time. Amplitude is 3. So from our new origin, we're going to go up 3. What is that? Go away. So we're going up, from our new origin, we're going up 1, 2, 3 additional points. Now you'll need to label this correctly on the test. What point are we at if we went up 3 additional points? We're at point 4. So you'll draw in your asymptote where your amplitude is, just so that we can keep our graph really pretty. And then we're going down 3 as well. So from this new origin, we're going down 1, down 2, down 3. So what point will we be at? Negative 2. So drawing in my asymptote here. Any questions on that part? Okay, done with our second step. Third step is to draw in the number of cycles. So how many cycles do we have? 1. It's what's multiplied in front of theta, so we have 1 cycle. Now, is this a sine or cosine cycle? It's a sine. We know our sine cycles start at the origin. They bounce all the way to the top, all the way to the bottom, and back to the origin. That's what 1 cycle looks like for sine. So starting from this new origin, we're going to bounce all the way to the top where our amplitude is, all the way to the bottom where our amplitude is, and back to our new x-axis, this pink x-axis. And now we're done with our third step. Our fourth step is to get specific. So we have to have those 5 specific points, those 5 special stopping points. So fourth is to be specific. In fact, I'm going to do it over here so I have room to write. So fourth is be specific. So remember before we shifted this, you guys, before we shifted it, we had those 5 special stopping points. They're always the same for sine and cosine. As it goes around the unit circle, we start at 0. Then as we go around, think where we hit next, we hit pi halves. As we keep going around, then we hit pi. Continuing around, we get 3 pi halves. And as we continue around, we'll go back up to 2 pi. Yes?
Do you know if all the ACT are going to have the unit circle?
Good question. I'm trying to remember if they do. I don't think they draw it out for you. Yeah, good question. I don't think they draw it out for you.
Well, no, would they have like a question like the pilot?
Yes, the trig questions will definitely be, you'll have one with a special right triangle or one where, yeah, you'd have to use the unit circle. Yeah, good question.
I have a question.
Uh-huh.
Sentence time.
Questions. So let's keep going with this. Okay, so now from here, we have our 5 special stopping points, and we know that they stop. And so 1 is our starting point. 1 is when we hit the very top of the amplitude. Now on our actual x-axis is where we're going to be labeling it, so right there. We just hit the top of the amplitude at our x-axis right there. Then our next one's when it crosses our x-axis, our pink x-axis, but on our actual x-axis we're going to be marking it right there. And then when it hits the bottom of the amplitude again, now once again on our actual x-axis, that's about right there. And then back to our starting point, back up to our x-axis, our pink x-axis, on our actual x-axis, that's right there. So we're labeling those points. So now remember, they used to stop at 0, pi halves, pi, 3 pi halves, and 2 pi. We're shifting them back by pi fourths, so we'll just subtract pi fourths from all of those. So our first stopping point will be negative pi fourths, which we already have that, negative pi fourths. Now you'll use your calculator for this. You'll do, so we're doing pi halves minus pi fourths. To get a common denominator, that's going to take too much time. Use your graphing calculator, but use it correctly. Put it in parentheses, do 1/2 minus 1/4, and you're going to get pi fourths. So our next stopping point was at pi fourths. And then once again, you're going to be doing pi minus pi fourths. So you'll do 1 minus 1/4 on your calculator, and you'll get 3 pi fourths. So this is 3 pi fourths. Continuing, 3 pi halves minus pi fourths. Once again, you'll do 3 halves minus 1/4 on your calculator, and you'll get 5 pi fourths. So our next stopping point is at 5 pi fourths. And then our last one is 2 pi minus pi fourths. You'll do 2 minus 1/4 on your calculator, and you'll get 7 pi fourths. So this is 7 pi fourths. So that's the 5 special points that you have to have labeled. This is what your graph needs to look like on the test to get full credit. This won't be multiple choice on the test. This will be fill it in. There will be one for sine, there will be one for cosine. So just make sure you practice it. But it's the same exact thing. Cosine stops in those 5 places, and it's the same. Okay, questions on that? Those take up a lot of paper, but you guys, those should be really quite easy. If you follow this process, you should get those right. Yes. Yes, sir? Okay. Awesome. Okay, moving on to the next problem here. Okay, so these are good ones. So it says, find the area of triangle ABC if angle A is 92 degrees, if B is equal to 4, and if C is equal to 7. So the first thing I'm going to do is something like this, and there will be a few, because he straight up told me, I'm going to make a lot of them like this, because it makes them have higher order thinking. So you have to be able to draw your triangle. Now this triangle doesn't need to be perfect. Everyone's is going to be different as long as you label it correctly. So I just do a triangle, and I just went ABC, ABC, and then you know that the angle C corresponds to the side across from it. That'll be C. Angle B, the side across from that will be B, and angle A, the side across from that will be side A. So angle A is 92 degrees, so I'm putting in what I know. So that's 92 degrees, and then it says side C is 7. So across from side C is 7, across from side B is 4. Okay, so now once again, ask yourselves, what are we getting asked to do here? Because you wouldn't want to go through extra trouble of doing the law of cosines when it's very unnecessary for this problem. Looking at this, we're asked to find the area of this triangle. So to find the area of a triangle, now this is not a right triangle, because if it was, we would just do 1/2 times base times height, right? But then, like I said, on an ACT2 especially, you could see something like this. You're like, okay, I need to find the area. It's not a right triangle. So then we know the formula is going to be area is equal to 1/2 times by side 1 times by side 2 times by the sine of the angle in between those two sides. So I'm going to say sine of angle. And it's going to be the angle between those two sides. That's what's important. Does that make sense, everybody?
Yes.
So area is equal to 1/2. So now looking at this though, if we were not given the angle in between those two sides, we would have to use the law of cosines to find that angle, right? But we are given the angle with two sides in between, so area is equal to 1/2 times by 7 times by 4 times by sine of 92 degrees. Now this entire test, you're going to have your calculator in degree mode, so keep that in mind. So area is equal to, you'll type it into your calculator, 1/2 times by 7, times by 4, times by sine of 92 degrees, and you should get 13.99. Now, if I said round to the nearest tenth, we would be rounding up, so the only way of rounding would be 14. So our area is equal to 14. Okay. So one last final example, then you'll have the rest of the time to work. So this one, it says find angle C. So once again, it says find angle C. So remember that we'll always try to start out by seeing if we can use the law of sines, because the law of sines is a lot easier than the law of cosines, but there's going to be times when we can't find it. So we're trying to find this angle right here. So if we were going to use the law of sines, we'd have to be doing, now I'm going to test out the waters. Let's see if we can do it. So we're going to be doing sine of angle C over the side across from C, which would be 26, which is equal to, we'd have to be using, the only angle we know is this 100. So we'd be doing sine of 100 over, yikes. Do we know that side?
No.
No. So we're not going to use the law of sines for this problem in the beginning. So I'm going to, do you all see why we can't use the law of sines for this problem? So then automatically we should be saying, well, okay then, fine. We are going to have to use the law of cosines. And you could also say we're given two sides with an angle that is across from the unknown side. Then you use the law of cosines. Okay, so law of cosines says if we have a squared is equal to b squared plus c squared minus 2 times by b times by c times by sine of the angle that corresponds to the unknown side. And remember, we always put the unknown side on the outside, right? Or the unknown angle on the outside. Okay, so sine of A in this case, right? Now, on the test, I would suggest just writing down one of those. You don't need to write down all of these individually, because hopefully we know how to apply it. Okay, so looking at this, we're trying to find A squared, right? Which is actually what we're trying to find, right? In this one?
Yeah.
Okay, sweet. So we're going to be doing A squared is equal to B squared, so it doesn't matter which order. So I just did 26 squared plus by 18 squared minus 2 times 26 times by 18, and then sine of 100 degrees. So now looking at this, we're trying to solve for A. So keep in mind what you're trying to solve for. We're trying to solve for A. Now looking over here on the right of this equation, we could actually type all of this in. There's no variables on the right side of this equation. This won't always be true for the law of cosines, because sometimes we use the law of cosines to find an angle. But looking at this particular problem, on this side we don't have any variables, right? So we can literally just type it into our calculator as it is. So I would save myself time and just type it in, but make sure you type it in correctly. If you do, you should get A squared is equal to, and you're going to get 1,162.534,694. And now we have A squared, but we just want A, so what will I do? Square root both sides. So on my calculator, I would just do, there's many ways of doing it, but I just do I do square root of second answer. That's not the only way. So A is equal to 34.1. So A is equal to 34.1, but is that what I'm actually looking for?
No, that's just.
Thank you. Yep, so we found side A, but we need to find angle C. But now because we found side A, we can use our law of sines. So we're going to be trying to find angle C. So let's set up now using our law of sines. So we'll be doing sine of C over the side that corresponds to C, so over 26, is equal to, so we can set up our law of sines because we have sine of 100 over the side that corresponds to it, which we just found was 34.1. Okay, so now we're trying to solve for C piece by piece. So now we'll cross multiply. We'll multiply both sides by 26, but it's going to divide out over here. So now I'm not going to multiply this through because then we'll just be redividing it. So we have sine of C is equal to 26 sine of 100 over 34.1. Am I okay to erase this so I can just keep my work nice and pretty? Is C alone yet? No, how do we undo sine so we can get C alone?
The inverse of sine.
Good. Sine inverse of both sides. So now inverse cancels out with sine. We have C is equal to the sine inverse of all that stuff. So you'll type that into your calculator. Sine inverse of 26 sine of 100 divided by 34.1. And then let's round to the nearest tenth.
48.66.
Let's see. Well, yeah, I didn't do this one. So what'd you get?
48.66.
48.66, so 48.7. Okay, so we got that angle is 48.7. So then this one, it would be easy to find angle B now, wouldn't it? If we wanted. Okay, we don't want to though. Then we're done. But we could, because we do 180 degrees minus 100 minus 48.7. Okay, questions on this? Okay, you guys are all set for the test. Now you can do that entire worksheet. There will be story problems on the test. Just draw out the picture, you guys. Practice those. Draw out the picture. Don't let them psych you out. You got it, okay? So practice the review.